All right, so this is going to be the lesson for 3.2, velocity time graphs. Uh, Now the do now question says describe the motion of this object in this graph. And now if you think about it, you'll realize that this is one of the homework questions for 3.1. Right, so let's take a look at this graph right here. So for the first 4 seconds, right? So for the first 4 seconds, again, this is a position time graph and displacement versus time, which is essentially position versus time. I'm going from a position of 0 meters at 0 seconds, and at 4 seconds, I'm then at a position of 8 meters. 8 meters. Right? So essentially, I'm going from a position of 0, right? So I'm going from this position of 0. And then I'm going to a new position of 8 meters. Right? So 8 meters. And then for the next 2 seconds, you'll see that, well, my position at 4 and 6 seconds is still 8 meters. Right? My position at 4 and 6 seconds are still 8 meters. So I'm literally just standing there. I'm not moving at all. I'm just standing there. And then from 6 to 8 seconds, right? It's from 6 to 8 seconds. From 6 to 8 seconds, I'm going from 8 meters to a position of 16 meters. And I should probably erase part of this. And we'll erase part of that. So you're going from a position of 8 meters to 16 meters here, right? So you're going further now. And then in this graph over here, right, this part says, well, from 8 to 10 seconds, I go another 8 meters, but I'm going 8 meters in the opposite direction. Right, so I'm going 8 meters now in the opposite direction here. And so that's what's happening in this graph, right? I'm moving in the positive direction for the first 8 seconds, and then from 8 to 10 seconds, I'm then moving backward in the negative direction. And so if you think about my total distance traveled here, right? So my total distance traveled here, I essentially traveled a total distance of 24 meters. Because I went up here 8, another 8 meters here, and I went backward another 8 meters. So in total, I traveled a distance of 24 meters. Now, my displacement is how far you are from your original starting location. So if I end at 10 seconds, if I ended at 8 meters, and at 0 seconds, I started at 0, well, I am 8 meters essentially from where I started. So my distance traveled here would be 24 meters, and my displacement here would be 8 meters. So that's essentially what's happening there, right? Essentially what's happening. And now let's move on. So let's go into velocity time graphs. So again, this topic is about something we call velocity time graphs. So let's say I have a, we'll let the simulation load, right? We'll let the simulation load. So we go back to the simulation now. And let's say our velocity of this person here is 2.5 meters per second, right? So he has a positive velocity and he's going to go to the right. So if you take a look at your position time graph, well, your position time graph measures position over time. So wherever he is, that's where he's going to be. All right, so at a time of 2 seconds right now, you'll see that at a time of 2 seconds, his velocity, and we're at his position, is at around 5 meters. And so his velocity here is 2.5 meters per second. 2.5 meters per second, and he's at a position of 5 meters. So a position time graph would tell you that, well, at a time of 2 seconds, his position is 5 meters. And if his position at 4 seconds was 10 meters, well, the dot would be there, and then you would connect the dots, right? So you would connect that. So that's a position time graph, measures the position over time. A velocity time graph, though, measures velocity over time, and which is what you see down here. You see it on this red line. You see on this red line, right? So my velocity here is a constant velocity of 2.5 meters per second. So you see this straight line here, and then that's going to be a constant velocity because, again, a velocity time graph measures velocity over time. And my y-axis here on this bottom graph here is velocity. So it tells you your velocity at any given moment. Right? And so at 4 seconds, if we continue the simulation, I want you guys to look at the velocity time graph at the bottom. If we continue the situation for the next 5 seconds, you'll see that, well, then he stops at the end, but before this drop downward at 4 seconds, you'll realize that, well, this person's velocity is constantly 2.5 meters per second, right? It doesn't change. That's his velocity at any given point in time. Now let's give this person, now let's say this person is standing still, right? So his velocity is now 0. So the red line is going to be at the y-axis of 0. So he's just standing there, right? He's just standing there now, right? And so at 8 seconds, at 6 seconds, at 4 seconds, his velocity was 0, which is why you see the line on your velocity time graph on the bottom. It reaches, it's labeled, the line is at 0, or y-axis of 0. And if he has a negative velocity, right, let's say his negative velocity is now negative 6 meters per second, well, where would you expect to see this line, right? If you have a constant velocity of negative 6, well, you would expect to see it. You would expect to see the velocity here, well, the line to be here, right? Because your velocity would be negative 6. So at this point in time, 8 seconds would be negative 6. At 10 seconds, it would also be negative 6. And this is exactly what you see, right? The person travels in the opposite direction now because he has negative velocity, and your velocity time graph says that he has negative velocity. All right. And so now let's get back to this. So I want you guys to be able to, well, let's try and analyze what's happening in this velocity time graph here. And so let's look at 1 second, this 3 seconds and 5 seconds. This is 2.5, and this is 7.5. So at 0 seconds, my velocity is 0, right? Because if you look on the y-axis, my velocity there stays at 0. And at 1 second, my velocity is 2.5 meters per second. And at at 1 second, its velocity is 2.5 meters per second. And at 2 seconds, my velocity is 5.0 meters per second. At 3 seconds, my velocity is 7.5 meters per second. And at 4 seconds, my velocity is 10 meters per second. And at 5 meters, at 5 seconds, our velocity is 10. And at 6 seconds, our velocity is 10. So based on this graph, what can you tell me about this object from 0 to 4 seconds? You can clearly tell from your y-axis that your velocity increases as you go from 0 to 4 seconds, which means you do have an acceleration here, right? You are accelerating, you're accelerating at a certain pace. And if you take a look at 4 to 6 seconds, you'll see that my velocity here is not changing, which means it's constant. So I have a constant velocity from 4 to 6 seconds, and my velocity is not changing, right? And then from 0 to 4 seconds, my velocity is I'm accelerating. Right? I'm accelerating here. My velocity is changing. Which now we get to this next part here. And we get to the next part here. We're getting to slope, right? And then the last lesson, last topic, we said that, well, the slope on a position time graph gives me velocity, right? The slope on a position time graph gives me velocity. So my y-axis here, right? My y-axis here. So let's talk about what slope is. And my slope here, as it says on this slide, well, it's delta y over delta x. Right, and my delta y here, right, with my delta y is essentially, if you learned in math class, it's y2 minus y1, x2 minus x1, right? So that's essentially slope. So the next question, the question you see here says, what is on the y-axis and the unit for the velocity time graph? Well, your y-axis gives you velocity. So velocity is meters per second. And on the x-axis, your x-axis is time. Your x-axis is time. So your slope essentially here would be y over x, so v over t, velocity over time. And if you were to do your units, right, you would essentially use meters per second divided by second. And the units you would get, the units that would be resolved here when you divide by seconds, is you would get meters per second squared. Right, you would get meters per second squared here. So what quantity has those units you just made? Right, which quantity? Well, you have to realize again that, well, the units here, meters per second squared, is acceleration. So we can basically say that the slope on a VT graph gives us acceleration. Let's do some practice on that, right? Let's do some practice. So the first question here says, what is the acceleration of this object at a time of 2 seconds? Right, at a time of 2 seconds, what is the acceleration of my object? So what you guys have to do here, what you guys have to realize is that, well, to calculate the slope, we want to calculate the slope of the line that the coordinate is on. Right, because they're saying here at 2 seconds. So your coordinate is at 2 seconds on the line. And well, what line is this on? Well, it's on this line right here. Right, it's on this line right here. So essentially, we want to calculate the slope of this line. We want to calculate the slope of this line. Well, then my slope is delta y over delta x, right? Which is essentially your change in y over your change in x. So you're doing your second y minus your first y, and your second x minus your first x. So your second y here is 5. Your first y is 0. Your second x here is 2. And your first x here is 0 as well. So your slope essentially is 2.5 meters per second squared. Now, and this is essentially my answer. So this is my acceleration. So now let's take a look at the second question. Let's take a look at the second question. So what's acceleration at a time of 6 seconds? Right, at 6 seconds. So my coordinate is right here because it's on that line. It's on that line. And that coordinate, the line that this coordinate is a part of, is this straight line over here. Is that straight line over here. Now, I know many of you guys will essentially, well, when you're doing delta y over delta x, you're going to say, well, my delta y is 10 because you see that your y-axis there is 10. And then you're going to do 10, and then you see your x-axis is 6. And then you're going to get something like, I don't know, what is this going to be, like 1.6 something, 1.66666, and so on and so forth. But you cannot do that. And this is why it's very important here that you take the slope of the particular line that the coordinate is on, which is essentially the straight line only. So my second y here, the second y of this coordinate at 6 seconds is 10. And the y coordinate at 4 seconds is also 10. And then my delta x here, my delta x would be essentially my second x would be 6, right? So I'm going for 4 to 6 seconds. That's essentially where my line is from. So 6 minus 4, so you have 0 over 2, and you get 0. So my slope here is 0. My slope here is 0. Which makes sense because, well, your velocity here is 10, at 5 seconds is 10, at 6 seconds is 10. You're moving at constant velocity, and your acceleration is not changing, which means your acceleration here is 0. Right? Acceleration is the change in velocity over time. I'm going to do the same thing over here. I'm going to do the same thing over here. So what is the approximate acceleration of this object at a time of 4 seconds, which is, I'm going to use a lighter color, right? Let me just use red. So at 4 seconds, your coordinate is there, right? So you're on that line. Well, I'm going to take this line over here. I'm going to take that part of the line. So my slope, again, is delta y over delta x, y2 minus y1. I'm going to skip that part. So my second y here at 4 seconds is 10. My first y, which is at 3 seconds, is 20. My x, my second x is 4, right? I'm at 4 seconds. And my first x is at 3. So it's negative 10 over 1, which is negative 10 meters per second squared. And this would be my acceleration. This would be my acceleration. So let's do the question on the bottom. What is my acceleration of this object at a time of 9 seconds? Well, you'll see that at 9 seconds, my coordinate is on this line, this particular line. And you can either take this entire line or just half of the line or part of the line. It doesn't really matter what you do as long as you're consistent. So when we do my slope again, delta y over delta x, my delta y, second y, is 9, right? Oh no. At 9 seconds, my second y is negative 20, right? At 9 seconds, my velocity is negative 20 there, minus my y at 7 seconds, which is also negative 20. My second x is 9, my first x is 7. We have 0 divided by 2, which we get 0. So essentially our acceleration here is 0. Our slope is 0, our acceleration is 0. So now enough of slope. There's something else there's some other type of information we can get from a velocity time graph, right? So remember area. Let's go back to area. Area is essentially your width times length, right? So area is your width times length. Area is width times length or length times width. It doesn't really matter how you guys approach it. It's length times width. What's the length of a velocity time graph? The length of a velocity time graph is my time, right? So my time is t, and I measure it in seconds, right? So it's time. And my width on a velocity time graph is my velocity. So it's time times velocity. And if you take a look at your units here, your time is measured in seconds, and your velocity is measured in meters per second. And if you were to resolve your units here, again, this seconds is on the numerator, so essentially it's the same thing as s over 1. It's on the numerator. So if you multiply these two units, right, the seconds cancel out, and you're left with meters. Well, what does area of a velocity time graph give you? Well, it gives you, on a velocity time graph, it gives you distance or displacement, because that is how you measure meters. Meters is a unit for distance or displacement. Distance or displacement. That's essentially what it is. So we can assume here that The area underneath a VT graph represents displacement. All right. So let's do some practice with that, right? Let's do some practice. So what is the displacement of this object from 0 to 1 second? Right, from 0 to 1 second, we want to get essentially this area underneath that line, the shaded area I have in red. And how do we calculate the area of a triangle? How do we calculate it? We're doing 1/2 base. My base is 1, right? So I go from 0 to 1. My base is 1. And my height, and I go from 0 to 10. Well, I'm going to 10. And so my answer here, my distance traveled or my displacement would be 5 meters. My displacement would be 5 meters. And then we take a look at the second question. What is the displacement of this object from 2 to 4 seconds? So you're essentially doing the same exact thing. Let me use a different color. Except if you're going from 2 to 4 seconds, right, this area that's underneath the line, we can't really, there isn't an area for this entire shape, right? There isn't really a formula for that. Well, what do you think we need to do? Well, we have to calculate area 2 times. We have to first calculate the area of this triangle right here and add that area to the area here of this square. So let's do just that. The area of that triangle, again, is 1/2 base times height, right? So it's here. 1/2 base times height. So my 1/2 base, which is 2. My height here, my height would be 40 to 20, right? So if you take a look at your y-axis, 40 to 20. So my height here is 20 meters, and my length, or rather my base, would be 2, right? Because you go from 2 to 4 seconds, so your length would be 2, and your height would be 20. And you would get 20 meters here, right? You get 20 meters. Now let's do the square. So the area of the square, right, is length times width. So your length here would be 2, right? You're going for 2 seconds. And your height, or rather your width there, would be 20. So you get 40 meters here. And then your total displacement would be 20 plus 40 gives me 60 meters, and that essentially is my answer, right? So I have a displacement here of 60 meters. Let's do some more practice questions, right? Let's do some more practice questions. What is the distance traveled for the first 4 seconds? So again, this is essentially just a simple thing. You're essentially you're going from 0 to 4. This is your line, so you're taking the area underneath your line, right? So your area of this triangle is 1/2 base times height. 1/2. Your base is 4. You go from 0 to 4, so your base is 4. Your height is 10. And so your area here is 20 meters. So you travel a distance of 20 meters. What was the distance traveled for the first 5 seconds? Right, so for the first 5 seconds, you're gonna add this area of this triangle in addition to this rectangle. Right, so you want to calculate the area of this rectangle over here. Let's do that. So this area of this rectangle is length times width. My length is 1, right, because it goes from 4 to 5. And then my width here would be 10, right, so because I go up 10. And my area here will be 10 meters. And then my total distance, because again, we need to add the triangle as well. So we're going to do 10 plus 20, because we want for the first 5 seconds. We're going to do 30 meters, and that would be my total distance traveled. Okay, That's a lesson.